Hi everyone, and welcome to another next week project. I hope you are feeling excited about this one, a highly requested topic. Today we're going to be talking about containerizing a RAG API with Docker. Let's learn how professional DevOps engineers package applications for consistent deployment. Now, first things first, you might be thinking, oh man, I do not know what Docker means. Don't worry, we'll be doing all of this from scratch together. And really, I think come into this project with just a learner's mindset if you're a complete beginner, because we'll be going through every single concept from scratch. Now, this project is given a pretty spicy difficulty because of that conceptual learning curve. Docker comes with some cool concepts like containers and containerization. So we're going to be talking about that today. Give yourself 90 minutes to do this project. If you have already worked with containers before, then you know that it's probably going to take a little less than 90 minutes. But don't worry, regardless of whether or not you're a beginner or someone that's experienced with containers, it's going to cost $0 in tool costs to do this project. Now, this project is also part 2 of a 5-part DevOps and AI series, which we can talk a little bit more about in just a second. So, get ready to learn about things like Docker, Docker Hub, FastAPI, RAG, Chroma, and Ollama. Now, because this is project 2 of a 5-part series, you might find these concepts familiar because that's what we went through in project 1 of the series. So we, in project 1, built a RAG API using FastAPI, using Chroma, and using Ollama. But if you haven't done that project yet, don't worry. We still go through the main setup for project 1 at the start of this project, so you can still do this entire project without doing the previous one first. Now, Docker and Docker Hub are definitely kind of like the stars of today's project because we're going to be learning how to containerize a RAG API that we built using Docker, and in our secret mission, we're going to learn how we can share that Docker image or that template we've created with the world, how to make it public by publishing it in Docker Hub. So let's wheel things back a little bit and talk a bit about, why does Docker exist, or why is it such a big deal? So how do big companies like Netflix, Uber, and Spotify make sure their apps always work well and the same way? Whether they're running on a laptop, a company server, or in the cloud. They use modern DevOps tools to do that. This includes using containers to bundle up their code and dependencies so applications run identically anywhere. Your laptop, a teammate's computer, or a production server. Honestly, this is a huge deal because if you have created apps before, or if you've wanted to share your app with someone else before, you might have gone through that problem called the "it works on my machine" problem. So this is a problem where, to build and run your app, along the way you've had to install a bunch of packages onto your computer, and your code relies on the environment having those packages to work. So if you wanted to share your app and the code says, oh yeah, use this package to do this thing, but say your teammate doesn't have it, or a certain server doesn't have it, then your app's going to crash. Even if your code seems to work, the environment itself is lacking things that makes the app run. So containers is a solution that helps to make sure that wherever your app is, it can run and it wouldn't crash because of some sort of environment issue. Because everything that is required of the environment is all already included in that container package. So what are we containerizing today? What are we packaging today? So we're going to be containerizing a RAG API with Docker. If you've done project 1, you would remember that to even build and run our API, we had to install a few things. We had to install FastAPI, we had to install Chroma, we had to install Ollama so that our API could actually work. So the goal of having this container is that we can package up all of those things you had to install and set up into one single package. So if you wanted to share your RAG API with someone else and you wanted them to be able to run it locally, they wouldn't have to go through the pain of doing all of that installation themselves too. Okay, so if you haven't done project 1 yet, you're like, oh my gosh, RAG API? What is that even? No worries. You don't have to complete project 1 first, although we highly recommend it. But we will also guide you through a quick setup at the start of this project so that you can catch up. Either way works. We also still explain what is a RAG API, or like what is an API anyway, at the start of this project, so that you can definitely still get all of the key details before we start containerizing and packaging everything. So expect that by the end of this project, you're going to have a Docker image of your RAG API and your image that's shared to the world through Docker Hub. And this is a little visual, or a little teaser of what's up ahead. So containerizing your RAG API, you can basically change your RAG API with application. Containerizing an app with Docker. How does it actually work? First, you got to build the application, build the thing that you're trying to package up. Next, you have to write the instructions for running your app inside something called a Docker file. But actually, the Docker file is more than just instructions for running your app. It's actually instructions for building the package, instructions for building the container. But what's going to happen is a Docker build happens, and what that means is we're going to use Docker, and you say, "Hi Docker, read my Docker file. It contains instructions for how to create a package." And Docker's going to go ahead and read your Docker file and go through those instructions that you've specified in your Docker file step by step so that it can create an image, which is basically that package, or that, we'll call it like a package of your application. So what's the point of having a package if it's not actually running? So having a package is one thing. Actually having a container, running that package, is a completely other deal. So next step is you would actually want a container to be running that image that you've got so that your application is actually running. You can think of it as, I was trying to think of an analogy. It's kind of like, say you wanted to package up this really delicious meal, and you said, all right, I've written the recipe for that meal, or like how to create this meal, and Docker goes, takes that recipe and makes like a very good instant version of your meal. Anyone will be able to grab it, pour some hot water in it, and they'll be able to enjoy your meal straight away. But imagine if all Docker did was actually just create the package, create that instant box, but no one's actually grabbing the box and pouring the water and actually eating the meal. That's kind of like what happens if you just create an image without having a container running it. So you're definitely going to want to have containers running your image so your application is actually running too. That was such a funny analogy. I just pulled it from the top of my head. I wonder if that's going to be helpful. Give me feedback on that one, team. All right, so this is the last 3 bits. Is the secret mission part of this project, where now that you've got your image and you can actually run it on any container, you can also push that image, publicize it on Docker Hub, so anyone in the world can actually pull your image, run your container, and use your API too. Awesome. So this workflow that we just looked at is the same workflow that many professional DevOps engineers use to ship AI workloads into production and at scale. The best part of this project is that you get to experience all of that, and Docker runs locally on your computer with no cloud costs or fees. So expect that this shouldn't cost a single dollar today doing this project. Okay, so we've talked a little bit about why Docker, but you can definitely expand on this, explore a little more, learn these different little, keywords that come in the definition of Docker. You can definitely use the project guide for that. And again, if you don't have any experience in Docker, no worries at all. We're going to be explaining all the concepts along the way, and you can always ask questions as they come up. So we've got a handy tool here that you can always open just using the Ask button like this. So you can pop it open and just type in any question that you've got. Whenever we want to prompt you to maybe ask a question and explore something, you can also just click on these little buttons that will come up throughout your project so you can ask extra questions. Just press enter to send off your question, and the ask is definitely going to respond to you ASAP. If you ever have any question, yeah, don't hesitate. Just click on ask, type in your question, press send. Awesome. Now, everyone learns differently, and in this video, this demo today, we're going to be going through the step-by-step guidance version of this project. We're just going to go into the most extreme level of detail, so that we're going to do every single click, every single thing that we're typing, all of that together. If you're ready to challenge yourself, say, hey, kind of just tell me what to do. You don't have to tell me how to do it. Let me figure out the how. That's when you go for some guidance. Okay, and on your own is when you are completely on your own, where you just get the high level of what you're supposed to do, and there's even less guidance here. It's almost like you just get a briefing, and whereas some guidance gives you at a high level at least what tools you should use, and at a high level what kind of things you should do in each tool. Okay. Great. So in the step-by-step guidance version, get ready for lots of detail, and we're going to answer every single question together too. And there's always a handy little quiz that you can try at the start of the project to just jog your brain a little bit. We're going to get into active learning soon. All right. First question, what is the purpose of Kubernetes? Interesting. I'm so shook that we're asked about Kubernetes when the project is about Docker. Don't forget, they're two very different things, and Kubernetes is actually the next project in this series. But we do have a text file that talks about Kubernetes in this project, so that could be why it's shown up. No worries. Let's learn about the purpose of Kubernetes. Is it A, to package applications into isolated containers? Is it B, to run large language models locally on a computer? Is it C, to convert text into numerical representations for semantic search? Or is it D, to manage and orchestrate containerized applications across a cluster of machines? Ooh, which one do you think is the most complex one? Just pick that. That's probably Kubernetes. But looking at each of these actually map to a very specific and valuable tool in our setup. Packaging applications. Okay, I hope that sounds familiar. That's what Docker does. Running large language models locally on a computer. We actually touched on this in the first project of the series. It's actually Ollama that does that. And converting text into numerical representations for semantic search. So this one is dear Chroma. Chroma handles this part. That leaves D, managing and orchestrating containerized applications across a cluster of machines. That is exactly what Kubernetes does. And if this seems a little bit like, whoa, what's going on? Don't worry, we really dive into this in the next project. So what's the primary purpose of Docker? All right, I'm gonna give us a couple of seconds so that you can give this a go yourself. Is it A, B, C, or D? And I'm gonna come right back so we can check out the answers together. 1 second. All right, so the answer to that one is to package applications with their dependencies into isolated containers. I just noticed all of these answers are answers we just saw, so I'm guessing that was probably a familiar one to look at. Okay. Next question. What is Minikube used for? Is Minikube used for building and packaging Docker images? Is it used for running a local Kubernetes cluster? Is it for managing cloud infrastructure as code? Or for implementing CI/CD pipelines for AI systems? All right, so Minikube, again, is a tool that we're going to be going more into for the next project. In the meantime, just know that it is for running a local Kubernetes cluster for development and testing. Implementing CI/CD pipelines for AI systems, I wonder which tool that is. What do you think? There's also building and packaging Docker images. That looks like Docker for sure. And managing cloud infrastructure as code. It sounds like Terraform, doesn't it? What is this one? GitHub Actions is used for CI/CD pipelines. Look, I was thinking of that, I promise, because GitHub Actions we do introduce in the last project of the series, or the second to last one. Okay, what does the kubectl apply -f deployment command do? These are some specific Kubernetes questions today. Hey. But this one is about deploying resources defined in deployment.yaml to a Kubernetes cluster. I wonder what's going on. Our quiz questions are very keen to ask us about the next project. But I think this is a great teaser for what's about to come afterwards. Don't be like, if this is a little bit advanced though, because we do go through all of these concepts together. And a Docker file. We did talk about a Docker file just earlier. Is it about managing the deployment and scaling of applications in a container? Is it about specifying the steps to build a Docker image? Is it about creating a Python virtual environment? Or about defining the network configuration for a Kubernetes cluster? Docker file. I do think this is a great giveaway, isn't it? So it is about specifying the steps to build a Docker image. Think of it as the recipe book for creating a Docker image. Okay. And we'll be creating one in this project, actually. All right, so let's get straight into step one, which is to set up that RAG API that lays the foundations of today's project. So if you've done the project one of the series on build a RAG API with FastAPI, this will be super quick. If not, no worries, we'll set up each component as we go. That's all good. So in project one of the series, we just learned how to create a RAG API from scratch. And a RAG API basically means that it's an API that uses AI to understand your documents and then answer questions about them. So for example, I can send a request to my API and ask it very specific questions about me. I can ask very specific questions about next work. And as long as that API actually goes into a database of my documents to retrieve similar information that could answer my question, and then it passes all of those documents to an LLM and says, hey LLM, go and process all of these documents to help me string together a nice paragraph or a good response. Then that LLM is gonna, do the work, do the processing of the documents, send through kind of like a generated sentence or generated response, which the API then passes back to me. That's just the RAG API in a nutshell. You can actually see how it works in this diagram too. You ask that question, the API receives your question, it goes and grabs the relevant docs related to your question, and then it passes those documents to Ollama or our gateway to an LLM to say, hey, can you generate a proper answer? Here's the person's question, here are the docs related to it. Create an answer for me, please. So the answer gets generated here, and it gets passed back to the API, which is kind of like the communication tool or like the gateway that passes the answer back to you, so you get a response. Okay, so this step is pretty much about kind of making sure you've got that RAG API set up on your machine. It's going to be very quick. It's going to be just about checking your setup if you've already done project one and you've already saved all your resources. But if you haven't, we'll just set it up from scratch together. Okay, so we're going to set up a virtual environment too, and we're also going to run Ollama, which is that gateway to the LLM. Okay. So in this step, we are setting up a RAG API using FastAPI, oh, I think it's just fast like this, FastAPI Chroma and Ollama. The RAG API is an API that will use our own documents to answer questions or requests. For example, how it works is it receives a request from a user, retrieves relevant information or documents from a Chroma database, and passes the results to Ollama to generate a response with an LLM. Finally, that generated response, the API is also responsible for passing the generated response back to the user. Well done, well done. Okay, so we're gonna start this project by opening Cursor in your computer because that's where you will access a lot of your files for the API. If you don't have Cursor, you can also use another IDE like VS Code. That's totally all good. Or just download Cursor if you don't have an IDE at all. Now, once you open Cursor, you're probably going to see a homepage for Cursor. It's going to look like this. Let me just switch my windows so you can see it. Oh, here you go. I hope you can see that. So welcome to Cursor. And maybe I'm going to have the steps and Cursor step side by side so you can see both. Okay, and we're going to select Open Project from the Welcome screen. And then we're going to select our project folder called Network RAG API. You should be able to find this folder in your desktop. That's where we saved it in the previous project, like this. But of course, if you can't find the folder, if it doesn't exist, don't worry. Let's create it from scratch. You can always click into, desktop, and then you can click Create New Folder or New Folder. And then name it Network-RAG-API. This one's quite important. We're going to reference this exact name later in this project. And then select this project as your repository. So that's totally another option for you too. Okay. Whoopsies. So we've got the folder and we're just going to click open here. Cool. Oops, sorry, cursor crashed for a quick second. I think I accidentally clicked the close button just now, which is my bad. But once you've got your project open in Cursor, next up is that we're just going to check that we've got all of the required files that make up your API. You should have an app Python file. Okay, this is basically the code for your API or how it works. There is embed Python file. This is the script that creates embeddings. Now, embeddings are basically how you convert text into numbers that capture its meaning. The reason why embeddings are so important is because the database we talk about, the Chroma database, stores vector embeddings. So it's great for basically storing words that have similar meanings close together And the way that it does that is by looking at the embeddings of text and then seeing which numbers are close together. It will store it close together. When a user of your API asks a question, that question gets broken down into the embeddings of that question and then matched against the documents that are in your database to figure out, okay, which pieces of information have the closest meaning or the semantic meaning to the question that you're asking. And then finally, k8s.txt is your knowledge base document, which basically means this is all of the information we're putting into our database, into our knowledge base, and it's just a definition of Kubernetes. Kubernetes is a container orchestration platform used to manage containers at scale. Now we have got all three: app.python, embed.python, k8s.txt. So we can tick all of these off. Very good. And if you're missing any of those files, we have all of the code here, so you can create it from scratch too. And next up, we're going to set up the virtual environment. And this is the virtual environment that keeps your project's Python packages separate from other projects on your computer. The long story short is, when you've got a lot of Python projects, our API being one, if you've got a lot of different Python projects on your computer, it's very easy for all of the different dependencies and demands of each project to start to conflict or clash with each other. Some Python projects might require a certain version of something, while other Python projects might require a different version of the exact same tool. So if you're relying on whatever version your system is running, it's very easy for whatever project you're doing to not work or bug out. A way to manage all of this is to actually have a Python virtual environment, which is basically like an isolated workspace for all of your code, and in this case for Nextwork RAG API. To figure out whether or not you've already got a virtual environment, you simply just look for a venv folder in your directory. If you can see it, that means you created it in the previous project. Well done. If you don't see it, that's okay. You can always click on this to create it. Now that you have your venv, what we'll need to do is to actually activate it. So venv, actually, this folder includes a lot of the dependencies, and also a copy of Python itself is in this folder, so that all of the the different versions of whatever you need is all in here. And whenever you want to run your project, it's actually going to retrieve the version of the package that's stored in here. So every single Python project you've got has its own venv folder. Okay, we're gonna go ahead and click on Terminal and New Terminal to pop open this area where you can run commands and send those commands to your computer so it can do things like activating your virtual environment. Now I'm following the Mac instructions, but there are always Windows tabs available for you, and you can always use the ask as well if you ever feel like, hey, this command didn't work for me. Now to activate a virtual environment, we run the command source, and we're just going to run that here. Okay, and that means it's activated. And next up, for your Python dependencies, you will just need to check whether or not your virtual environment has the correct version, or actually just check whether or not your virtual environment contains the dependencies that we need in order to run our API. To do that, I'm just going to use this command here that's already ready for Mac users, and for Windows, there's already one here for you too. And this is going to just make sure that if we were to output a list of all of the Python packages that we've got in this environment, we should be able to filter the results and find the 4 things that we're looking for: FastAPI, Unicorn, ChromaDB, and Ollama. Let's run that. Okay, so it looks like we have all 4 here: ChromaDB, FastAPI, Ollama, and Unicorn. You can always just run this command to install any missing packages. Okay, so let's take a screenshot of our terminal. We're just going to show that we've got all of these installed. And did you know you can actually just copy and paste images from your clipboard? So what I'm going to do now is demo that for us. So I have a keyboard shortcut that basically lets me copy an image and save it in my computer's clipboard, I'm gonna go ahead and do that. I don't really like that Ollama runs onto a new line. Do you like that? Well, let's take that screenshot straight away. And as you can see, I'm just gonna try to take that. I just realized I actually took a version that doesn't save it to my clipboard. And then what you're gonna do is you're gonna hover over this panel, and you're just gonna press Command V or Control V so you can paste it from your clipboard. Beautiful. Okay, so what packages did you install and what is each used for? The packages we installed are FastAPI Chroma, Unicorn, and Ollama. All right, if you want some sort of reminder of what each of these packages are used for, the explanation is right here for you as well. Okay, so we can see that FastAPI is what creates your API. It handles web requests. It's what's going to make your app accessible over the internet. And Unicorn runs your FastAPI app. Think of it as a server that actually starts the API and listens for requests. So if FastAPI is the framework for your API, Unicorn is what actually runs the code. Now, ChromaDB is that database that we've been talking about. It stores the document embeddings, searches through them, so that if someone asks a question, ChromaDB is responsible for finding the most relevant information. Ollama is next, and it is how our API, Ollama, this Python package, is how your API will talk to Ollama, the LLM service, on your computer. So your API sends questions to the AI model that Ollama is running and gets the answers back. So when we put your API in a Docker container, all these packages need to be included. Checking they're installed now, make sure everything will work when we containerize it too. So let's answer this now. FastAPI is used as the framework for building our API. Chroma is used for storing the embeddings, the vector embeddings of our knowledge base information, and also retrieving the most relevant, our knowledge base's documents, and also retrieving the most relevant information for incoming requests. Next up, Unicorn is used for running our API. Finally, Ollama is used for communicating or connecting the API with the Ollama service running in our computer so that our API can talk to the LLMs and get the models to generate responses. Excellent. Okay, so let's move on to verifying that we've got the database set up. We're really like, how Thanos has this gauntlet of all these rings. We're kind of like just going to go through and just check that all of these different dependencies that we've got are working properly. And this starts with the Chroma database. Let's just make sure that, we talk about installing Chroma so that we've got, this Python package sorted. But in our previous project, we'd already created that database too. So let's just check that database actually still exists. In your project directory, we're going to open this up and just check that the database folder is in here. There we go, here it is. And you should be able to see your database's files already inside as well. Okay, so if you don't have it, don't worry. It just means you need to set it up from scratch. All you got to do is run the command for the embedding script, embed.py. You just need to run this, and it should be able to convert your document, k8.txt, into the embeddings that we store into our database. Okay, so no stress if you don't see it. You've got the instructions for it here. But if you see it and you can see your Chroma files inside, as long as you see this like strange long ID, that's the UUID that Chroma uses. So this confirms to us that our database is alive and well. Okay, so Chroma database tick. Next, we're going to run Ollama, which is the service that runs the AI LLMs locally on your computer. Okay. So first, we'll just check if Ollama is actually running, and this is a quick HTTP request to Ollama that helps us confirm if the Ollama service is even running. If Ollama isn't running, we are not getting to our LLMs. So we definitely need Ollama to be available so that it can open the door to the LLMs that are going to generate the responses for us. So let's go ahead and run this command in our terminal. Curl, and it says failed to connect to localhost port 11434, and that's totally okay. It just means that we just need to wake up Ollama. So let's go ahead and start it by running this command. Literally means open the Ollama app. So we're going to copy that, paste that in our terminal, run it, and we've got Ollama awake. Look at that. If you see this happy little llama, you know for a fact that Ollama is now running. But the best way to check it, the most reassuring way to check it, is look at your menu bar. Do you see the llama icon show up? You kind of have to. It helps us make sure that Ollama is actually running. All right. So if you get a response, after you run open Ollama, that the Ollama app is not found, here are the instructions for actually fully installing Ollama so that you can open it up. Okay. So once you've got that, you've opened Ollama, let's go ahead and run that command for sending that request to Ollama again. Do you think we're going to see that's running? Please. All right, Ollama is running now. So that was a very successful run of just opening up Ollama. If you have any more trouble, click on this handy little pop-out that helps you with troubleshooting this. Okay, so there's always help on the way. Or the Nextwork community too. Highly recommend jumping into the community so you can ask questions, do this project with someone else, or if you've already done the project and you'd like to share it with someone, the community is a great way to do it. Okay, so you should see Ollama is running. Beautiful. It tells us that Ollama is ready. It can open the door to take us to the LLMs that are going to generate those responses for us. And I'm catching myself that I'm saying kind of like Ollama is opening the door to the LLMs. So just a quick pause here in case it wasn't clearer. In case it wasn't clear beforehand, Ollama isn't the LLM itself. It's not the actual LLM that's going to generate the response. Ollama is kind of like a service that helps us run LLMs locally on our machine. So you can kind of think of Ollama as like this gateway to LLMs that we'll actually use. And in this project, we're going to use Ollama to access an LLM that's called TinyLlama. So TinyLlama is the actual LLM that's going to generate those responses. And because we have Ollama, we can actually run the TinyLlama model locally on our computer, so we don't have to rely on, other providers like Anthropic or OpenAI who will probably charge us for using their models. Okay? So we love TinyLlama because it's one of the smaller, faster models that you can pull from Ollama or you can access from Ollama. It's about 600 megabytes compared to the larger models that can be 2, 4. I've definitely seen even like 16 gig large language models that you'd have to download. Okay, so you might already have Ollama, especially if you've done the last project. So let's just check if you already have it using the command Ollama list, which is responsible for listing all the models that you've got access to with Ollama. All right, it says that I have got TinyLlama because I've installed it previously. So we've got TinyLlama in the output. And if you don't, here are the instructions for installing it. Okay, now the final piece of our setup is to just test the API ourselves. So let's just check The API that we set up in the previous project, is it still working? Let's hope so. So we're gonna run this command to start the API, basically use Unicorn, that web server, to run the code and actually get the API going. Okay, let's go. And I might just expand this window because we're gonna use it a little bit more now. Okay, and you can see that this is a successful message that basically says that Unicorn is successfully running our app. It didn't run into any errors starting up. That's a good sign. And the command we ran, Unicorn app, basically means look into the FastAPI app, and in the application file, that Python file, and make the API available at this specific address. So this is a specific address. That means when we want to request from our own API, basically ask our API question, we send that question over to the address. Okay, and if it says Unicorn is not found for you, it means that maybe you haven't installed that package yet, or maybe you don't have your virtual environment set up. So investigate which one it is. Okay, if you don't have your virtual environment set up, this command wouldn't work, because again, our virtual environment is responsible for packaging all of the dependencies we've installed into like a very specific workplace. It needs to be activated for you to be using Unicorn, which you've installed into. Okay, so we've got the API running now, which means our API is ready to receive questions. So the next thing we're going to do is to test it by opening a new terminal. Click on that new terminal button and run the command for querying our own API. Let's go ask it a question, see what it responds with, yeah? So we're going to open up that terminal and run that command here. What is Kubernetes? And oh no, we've got an internal server error. So what's going on? So if you've got an error, oops, I think this is further up. If you've got an error, you could always check here. Is a connection refused? Is it Ollama connection error, a request timeout, or other errors? You can always just pick which one it is. If you don't know what's going on, because it says internal server error, it's being a little vague, you can click on this tab here to have a look at what's going on. So it says client.generate got an unexpected keyword host. Oh my gosh, this is my bad, team. I accidentally saved the app Python file that's gonna work at the end of this project, but not at the start, because I was testing this project earlier. But my app Python file is definitely looked different by the end of this project. It's like a spoiler. But let me revert that. Let me revert this code now to what it should be, so we can test our API properly. 1 second, everyone. Okay, everyone, I'm back. I have reverted my API code back to what it should be. Let's save this, shall we? And once it's saved, we're gonna go ahead and just run the API one more time. Okay, shut down what was previously running. It's not the correct version. And let's get Unicorn to start up a server running the API one more time. Excellent. Okay, so off it goes. Okay, and let us switch back to this tab one more time, and let's query our own API again. What is Kubernetes? Oh, there we go. Kubernetes is a container orchestration platform, yada, yada, yada. So you've got the right answer now, doesn't it? It's been able to answer this question using the documents that are in our knowledge base. You know that it's using that document because it's using word for word what is inside our text file. Let's open up that text file. Look at that, a container orchestration platform used to manage containers at scale. Used our own document word for word. So good to see our RAG working properly. So we've got that JSON response, excellent. And this just proves that our API is working correctly. Well done. It means that we're ready for containerization. Excellent. Gonna go ahead and upload your screenshot, and then you can write your response here. How did you test that the API was working? Sweet. So we tested that containerization was successful. How do we do that? We did that by, I just realized I was using an old version of the placeholder, the filler text. Apologies, everyone. This is the correct version. So how did you test that the API was working? We tested that our API works by running our API in one terminal and then querying it ourselves in another terminal. The local API responded with what did it respond with? Do you remember? The local API responded correctly that Kubernetes is a container orchestration platform used to manage containers at scale, which are the exact words we added to our knowledge base. This confirms that our API is successfully using documents in our knowledge base to generate responses. Oh, it's successfully using documents in our knowledge base and generating responses using an LLM. The RAG system is working. Excellent. Very, very happy with this outcome. So let's go ahead, hit done for those tasks, and all checks have passed. Your API is ready to go. So now let's install Docker so we can containerize your API. Okay, so in this step, we're gonna install and set up Docker. Oh, it's a bit smaller now, isn't it? Okay, let's go back. So we're gonna install and set up Docker in this step. And Docker is the tool that's gonna help us package our API into a container, and that container basically means your RAG API can now run identically anywhere, whether you drop it into your teammate's computer or production server, doesn't matter. A Docker is responsible for making sure that you shouldn't run into too many errors because someone's environment isn't set up exactly the same way as yours. So containerization is basically the practice or the process, and Docker is simply one of the platforms that does it. And honestly, companies use containerization today to deploy thousands of services reliably, saving them hours of debugging and preventing costly deployment failures. Yeah, imagine if you decide to deploy your app into a cloud server or a virtual machine, and before you know it, your app goes down because your virtual machine doesn't have all of the necessary, dependencies in its environment. Okay. So this step is very, very clear cut. We're just going to focus on installing Docker Desktop. So in this step, we're installing Docker Desktop. Docker is a containerization platform, which means engineers use it to package up their application and all its dependencies into a container or into a package, so it can run the same anywhere. Okay, so let's install Docker now. We'll start by running the command docker version. Okay, as you can see, I already have Docker set up in my computer. It can take about 5 minutes to fully install it, which is why I've come a little bit more prepared. But don't hesitate to follow the step-by-step instructions here so that you can download Docker Test Desktop for your operating system. And we've got the step-by-step instructions for you too, on whether you'd like to install it for Mac or Windows. Here you go. All right. So if you see a version number like me, the steps that we should be taking is to just make sure that not only do we have a Docker version, let's make sure that Docker Desktop itself is installed. Okay, so it's totally possible for the Docker tool to be available, but you actually need Docker Desktop installed too, so that your containers are actually running, or that Docker can actually build the Docker image or that template that we were talking about. Okay, so I've got Docker Desktop running now. After opening it from my applications folder, you can always find your applications folder and whoa, look at this huge applications folder. And you should see Docker looking like this. Okay, so it's running. You can also confirm by checking for this little boat icon in your menu bar. Excellent. Okay, and now that we've got Docker installed, you can see the Docker Desktop dashboard. You can now respond to this. Let's answer this task that says Docker Desktop is, what is it? I realized we haven't really talked about Docker Desktop fully. Like, what's the difference between Docker and Docker Desktop? So shall we ask our handy ask here to explain what's the difference between Docker and Docker Desktop? I wonder what it's going to say. Ooh, okay. So Docker is the platform that enables you to create, run, and manage applications in containers. But Docker Desktop is that app that bundles lots of different tools that you need to run Docker into a single package and a single graphical user interface. So it's a lot more, I would say, a lot more easier to interact with. So Docker is the underlying technology for containerization, but Docker Desktop is a very convenient application so that using Docker is easy. Okay, so Docker Desktop is a user-friendly application that bundles the Docker engine, i.e. the core software that actually creates containers. CLI and other tools into a single package. I installed it because using Docker Desktop makes interacting with Docker, a lot more visual and user-friendly. Containerization will help our project by packaging our application into a single executable package. So it runs the same anywhere. Awesome. Okay, so now that we've got Docker Desktop running and you can confirm that you can see Docker in your menu bar, we can verify that Docker is working properly by running a simple command called docker run hello world. Let's go ahead and run it, and once we've run it, we can talk about what it does and what it means. Okay, so first things first, it says unable to find the image Docker world latest locally. So it pulls it from a library, and once it pulls it, it downloaded the image for hello world. We see something in our terminal that says hello from Docker. This message shows that your installation appears to be working correctly. To generate this message, Docker took the following steps. The Docker client contacted the Docker daemon. The Docker daemon pulled the hello world image from the Docker hub. The Docker daemon created a new container from that image, which runs the executable that produces the output you're currently reading. The Docker daemon also streamed that output to the Docker client, which sent it to your terminal. Interesting. So in short, you can see that there are actually a lot of different parts that come with using Docker. You've got a Docker client, a Docker daemon, and basically you can kind of think, Docker client, Docker daemon. So the Docker client you can kind of think of as, so the Docker daemon is kind of like the backend engine that actually runs the container, like it does the job. It runs the containers, it creates the image, it does the things that we expect Docker to do. And what about the client? The client is responsible for turning what you want into actions for the Docker daemon to perform. So when we are running a command like docker run hello world, Docker daemon doesn't immediately know what you actually want to do. The Docker client is responsible for knowing, okay, it wants to run a Docker command. Okay, this is what run means as a command. Hello world means that this is the image that you're looking to run. So it can, understand those things and then translate that into specific API requests or specific kind of actions for the Docker daemon to do. But in short, what this does is it's a great confirmation message that just tells us that Docker is working correctly on our computers. Okay, so let's take a screenshot of Docker working with that successful hello from Docker message. And then we've got a few tasks that we can respond to too. Oof, I'm not a fan of that screenshot. It's not very beautiful, is it? Let me try that copy and paste one more time. So let's go ahead, take a screenshot of that, hover over, press paste, bam, straight in there. And how do we verify that Docker is working correctly? We verified that Docker is working by running docker run hello world. And the Docker hello world container proved that Docker can download images from the internet, it can create and run containers, and your installation is working correctly. And this is all just very, very true. You might be wondering, like, how do we even run hello world? Well, the answer really is that the hello world image is stored in Docker Hub. It's stored in the internet. So even though we don't already have the hello world image locally, Docker was able to pull that from the hub so that you can use it. It's also good to see that Docker can create and run containers, because in order for us to be able to even see this message, it means that the container needed to be running and the messages from that container was passed back to us in the host machine using the terminal. So this wouldn't be working if our container wasn't running properly. So the hello world container proves that Docker can successfully pull images from the internet, or really from Docker Hub, and create and run containers. All right, so let's go ahead and select done. Now that we have verified that Docker is working correctly, and we are gonna move on to package our RAG API in a Docker container. Okay, I know we've been working together for a whole hour now. Can you believe? I think that hour passed by pretty quick. So here is a little timeline check. We are at step 3, the final step of this entire project. And then we're gonna spend probably another 20 minutes, if you've got that extra bit of time, to talk about that secret mission where you're gonna share your Docker image publicly through the Docker Hub. Now, let's focus on containerizing our API first. So containerizing the API, the other way to say it is packaging it in a Docker container so that it can run identically anywhere. So in this step, we're going to create a Docker file for your RAG API. We're going to build a Docker image of your RAG API, and then we're going to test that containerized API. So the Docker file is that text file containing instructions to build a Docker image, and the Docker image is that lightweight standalone executable package that includes everything you need to run a piece of software. It is a blueprint for creating the containers so that there's consistency across different environments. Okay, so I would say the simpler way to say it is basically, if you have your RAG API and you want to make sure that it runs the same everywhere, you're going to want to have containers that are running your app the same everywhere. And how do you make sure all of those containers are behaving in the same way? You make sure they're behaving the same way by making sure they're all running the exact same Docker image. So when you're containerizing your API, you're creating that Docker image that all of these Docker containers are now going to run. And then to create that Docker image, you have to write the Docker file that tells Docker how to build the Docker image exactly in the way that you need it to be. If you write that, hey, we want to containerize our RAG API, your Docker container should give some instructions that say, hi Docker, when you build this image, make sure to include that the Docker image should have already these packages installed. You should already have Ollama, you should already have Chroma, you should already have FastAPI and Unicorn set up inside. And then Docker's gonna go say, okay, following these instructions in the Docker image, Docker file, here's a Docker image that I've created. And now, whenever you want to run your application elsewhere, someone is gonna be creating a container and making sure that container is running the Docker image. So I hope that makes it a little bit clearer. Let's go ahead and explain what we are doing in this step. Okay, so in this step, we are containerizing our API. This means creating a Docker image that packages up our RAG API and all of its dependencies. In order to build that Docker image, we must write a Docker file first, which will contain the instructions for the Docker, for building the image. Aha! So let's create that Docker file. That has to come first, and we're going to create it step by step together. And the Docker file follows a specific template where each line in that file is a command or an instruction that Docker is going to execute in sequence from top to bottom. So first is from. From is like a command that specifies what base image we're building from. So in this case, we're going to use a Python base image, and in work directory sets the working directory inside the container. So for example, hey, let's just make sure all of the files are inside a folder called app. Copy brings your code files into the image. So it literally will say, hey Docker, copy the app Python file here and copy that into the image. Run executes commands, install Ollama, install Chroma DB. Docker is going to have to run those commands when it builds that image. Expose documents which port the app uses, and then command defines what command runs when the container starts. So there are a few packages that would actually ask like, hey, the moment you open or you start running this container, make sure you're running this command so this package is actually going to work. It's kind of like how, you know how when we were trying to curl Ollama and Ollama just wasn't responding until we had to say, okay, open Ollama, and we had to run that command separately. It's kind of like how, you know, we also have to open the Docker desktop app in order to actually run Docker. So there are going to be some things that do require a few commands to actually start it up so that it will work. And when you build a Docker image from this Docker file, Docker creates a layered read-only snapshot that includes your application and everything it needs to run so that the Docker image can then be distributed and run anywhere that Docker is installed. So another way to think about it is that every single line in your Docker file is called a layer, which is like a snapshot of a specific layer of your file system. So Docker actually caches these layers too. If you rebuild your image and let's say the port your app uses changes, that's just one layer, you know, that changes. And Docker will just rebuild the app knowing that every other layer has not changed. It's only this layer that needs changing. And that means building the image is very, very fast. So that's the benefit of caching. And that's the benefit of kind of breaking down the building of an image into layers. So that's an extra bit of like information for you for anyone that's interested about Docker files. And let's go on ahead and create that Docker file. Let's see it in action now. I'm going to minimize the terminal because we don't need it right now. And I'm going to open up my File Explorer, which you can do by pressing Command B. So let's create that Docker file. To do that, right-click on your project's File Explorer on the left-hand side and click on that New File button. And we're going to type in Docker file. Notice how I don't actually write any kind of file extension, like it's not dockerfile.txt or dockerfile.md, it's just Dockerfile. So press enter, you've now created Dockerfile and it's looking empty. We're now going to make sure that we actually have all of these layers of instructions inside our Dockerfile now so that Docker actually knows how to build an image. Okay, so we're going to make sure that, you know, all of this code is inside our Docker file. Now let's paste it. And if you can't read everything, a handy tip is you can actually press, I think, Control Z on your keyboard. Oh, was it FNZ? Nope. I think it might be Option Z. Press Option Z so that you can wrap your text around as well. So you can read everything. I also like to just hide my File Explorer again so I can just focus on the text here. And we can actually break down every single line together too. In this line, we're telling Docker to start with a pre-built image with Python 3.11. We're using the -slim variant of the 3.11 image, which basically means that only the essential parts of Python 3.11 is used here. I think one thing we haven't really talked about yet though is why do we need to start with a pre-built image? Okay. And while we're waiting, there's also the work directory app. So think of app as the container's project folder, kind of like how our project folder is nextwork-rag-api. The equivalent for our container is called app. And it makes sure that whenever we add a lot of files, because Docker's about to copy some files, all of them get copied into the same place. Okay, so Yeah, I think to summarize the reason why we're starting with like a Python pre-built image, a pre-built Python image, it just makes sure that we have a Python environment that can actually run our files. Don't forget, the app is a Python file, and we even have a Python virtual environment to make sure that we can actually run the code. So that's why we need to start with a pre-built Python image today. Okay, and the next line says run, and then there's apt-get update, and this updates the package list, and it's needed on Debian and Ubuntu-based images. Now, this is a little bit technical, isn't it? So let's actually break this down a little bit more. And you can actually ask like this, and you can say, this is a bit technical. What does apt mean? What does Debian Ubuntu-based images mean? So we're gonna run that, and then we're also gonna install and curl, so that we're installing curl. Curl is what we needed to use to check whether we've got Ollama working, and it's also needed for us to actually query our own API. So this one's a pretty important one to use. Oh, actually, I misspoke. What I was actually wanting to know, what does apt mean? Okay. And aren't we using a Python image? Why are Ubuntu or Debian mentioned here? Okay, so apt-get, apt stands for Advanced Package Tool. So it's like the App Store Manager for your Linux operating system. I see. And when we're saying that we're using a Python image, it doesn't mean it only has Python going. It just means that there's Python pre-installed on top of a base operating system. This base operating system is often a lightweight version of a Linux distro like Debian or Ubuntu. So there's a very, very base layer that determines like the operating system, like that level of the environment. And then there is the Python environment on top of that. So when we're doing run apt-get update, this is something that is needed on the Debian or Ubuntu-based images to update our package list, make sure that we have all of the packages that we need. And in this case, we need to install curl. So that's why we need to update the package list so that we can install it. Interesting. So we've got the next command on copy, so that we're copying all of the API's files into our image. And here we've got run, so that we're now running this specific command that installs the Python packages our API needs. Of course, running embed, Python embed, this Python file was something we needed to do in the first project of the series, so that we are creating the database files or the embeddings for our knowledge base. So it's cool to see like literally the commands we ran to set up our environment getting placed into the Docker file so that it can be replicated for the Docker image. Expose 8000. This tells us that your application or the RAG API is listening on port 8000. And then we've got a set of commands here that starts the app. So remember how we said command is basically the command you should run the moment your app is running, or the moment your container is running. In this case, this command should look a little similar or familiar because we ran this exact command when we wanted to test our own API. This is the command for running the API. Cool, so when you're ready, let's just save our Docker file, shall we? And the white circle next to the file name should disappear. Okay, so a Docker file is a recipe that tells Docker how to build a Docker image of our RAG API. The key instructions in my Docker file are to build from a base image, a base Python image, and to install dependencies, plus set up the environment via package installations, and creating the vector embeddings. That sets up the database. From tells Docker to build from a base Python image. Copy is used for copying the app's files from the local computer, or like from the local project directory. Run executes the commands for installing dependencies and creating the vector embeddings. Finally, command defines a command that the container should run on startup so that it's running the API. Excellent. Okay, so now that we've given a little discussion on what a Docker file does, let's go ahead and build the Docker image. So what does building a Docker image actually mean? Now, to build a Docker image of your RAG API, Docker is going to read your Docker file top to bottom, and it's going to run all of the instructions inside your Docker file and snapshot all of the results into that reusable image. So in your cursor terminal, we're going to go ahead and run that handy command that lets Docker read your Docker file and build that image. We're going to copy the code for building the Docker image here. I'm going to open that, use this terminal, open that terminal, and run the command like this. Okay, and this is going to take a little bit of time, so don't be alarmed if it's taking 5 to 6 minutes for this command to work, especially if it's your first time running a Docker build command. It can almost take some time for Docker to warm up. Okay, so this command says Docker build. Hi Docker, can you please build an image? Okay, Docker says, all right, what image do you want? So you already have a Docker file inside your project folder, and Docker is automatically going to say, I'm going to go into your Docker file that's in this project folder that you're calling me from, and I'm going to go build that line by line. And the only thing that this part does is it says, hey, once you're done building that image, can you please tag, which means name the image, RAG app. So the T stands for tag. You can think of this as giving your image a name so that you can reference it in other commands later on. The dot, uses that current directory as the build context, so Docker will know where to look to find that Docker file. Okay, so it's going to take about 3 to 5 minutes, but once that time's up, look at that. You're going to see that many steps were executed. Look at every single line in your Docker file getting run. And then you can see the build details. Here's a link to Docker Desktop where you can see more, but your terminal looks pretty happy. There aren't any error messages. Looks good. Okay. And every step, again, that layer concept, every step creates a layer in your image. So your Docker image is actually a collection of all of those layers. If you rebuild your Docker container, let's say something about the requirements for the dependencies you need changes, let's install one more thing. That's only one layer that's going to change, so the rebuilding is going to be a lot faster. That's why we say it should be about 3 to 5 minutes the first time you build your image, but it should be a lot faster after. Okay, so we're going to just double check that the image was created successfully by running this command that checks for all the images you've got, but it just filters for the specific image called RAG_app. Let's run this command now in our terminal, and there you go, you've got your answer. And our image is 1.35 gigs, pretty mega. I guess it's not a small image, but it makes sense if we've got 4 different things that you need to install for different kinds of dependencies. And in this RAG_app, there's the tag, the default kind of name called latest, and then here is your image's ID. Okay, so your image is built, it's ready to run. We're almost done with this project now. What's left is to actually test that the API still works when it's in a Docker image. So let's go ahead, take a screenshot, and add that to your documentation. And then let's have a look. Building a Docker image involves getting Docker to read our Docker file and then executing every single line from top to bottom. We verified our Docker image was built. Successfully by running the command that returns a list of all our Docker images, specifically filtering for the image titled RAG_app. Cool. This confirms that our API is now containerized because the code files were copied, the key dependencies, e.g. Chroma, are installed, and even the vector embeddings were created. The vector embeddings were created, and the command for starting the RAG API was run as a part of Docker creating this image. This encapsulates all the core things your environment would need to run this API. Okay, moving on. Now let's run the API in a Docker container. Once we've containerized it, let's definitely put it to the test. So you're about to see your API running in an isolated environment because it'll be running inside the Docker container, and we're simply querying the API that's running in the container. So to be clear, the image has been created, but we don't have a container that's actually running the image yet. So for us to be able to fully test this, we need to run the container first and then query it. Look, what's the difference between an image and a container? So the image, which is what we just built with Docker, is that read-only template of our application and all of its dependencies, and then the container is the running instance of that image. We're going to run the container using this command. So Docker run, again, is a very straightforward command that just says, can you run a Docker container? And then it's going to say -p 8000:8000, and that basically just says, in terms of port mapping, let's map port 8000 on your host to port 8000 in the container. So it makes the container's port 8000 accessible from your computer. So kind of peeling this back another layer, how ports basically work is when you have an application that's running, you can access that application by visiting the specific address where it is, sending and receiving requests. So in this case, let's say if we are running Ollama, we can curl that specific address. It was like 11434. It was one of the commands that we had to run to check if Ollama was running. And we'd only get the response, Ollama is running, because when we go and, let's say send a request to that specific port, that specific address on our computer, Ollama will show that it's listening there too. It will kind of meet us there. So by port mapping, we're basically saying that to access our container, we simply have to just visit port 8000 or that specific address in our local computer. And the local computer at port 8000 is going to be connected to port 8000 of the container itself so that those two can communicate. And before I forget, one important thing about what's the point of port mapping is actually comes down to how container networks work. So even though your computer is running a container, when you create a container, you know how we say containers kind of run an isolated environment and it makes sure that your apps runs the same and everywhere. A part of it having an isolated environment means that Docker containers typically can't be accessed by outside traffic until you explicitly create a port map. So in this case, the fact that we're kind of running on our hardware computer, that is on its own network. It does not automatically have access to the traffic that runs inside the container. So if we didn't have port mapping set up, our computer and our container would not be able to communicate, which means we would not be able to send queries or send questions to our own RAG API. So because of that, port mapping is very important when we want to run RAG app, our container running the RAG app image. Okay, so let's actually run the command, shall we? Just realized I did not run it before I started rambling and doing all these explanations. Okay, so docker run port. Ooh. Before we dive into the error, let's just double check that we've got the command all good. And right now we've got an error today, team. It says that there is invalid syntax, and there is. Look at this, import chroma db from, and there's no space. What are we doing today? What have I done in our application file? I'm pretty sure the import came here. Oh, what are we doing? We accidentally duplicated the import from FastAPI line. So I'm actually really glad we ran into this error, because now we can demo a change to a core file that makes up our app, which is now going to mean that and this import line is duplicated, which is going to mean that we need to rebuild our Docker image. So let's save these changes, these fixes, to our application file, our app Python file, and let's go ahead and rebuild our image by running that docker build command again. And this time it really should be a lot faster, because there's a lot that we don't need to rerun. Okay, and here this run command actually still needs to run, because now actually I was gonna say now we've made a few changes to the application file, but actually it could be because, was there any change here? No, but there was a change in how we define these packages, so maybe that's why this needs to be rerun. But as you might notice, these are all cached. Where Docker file correctly identified that there are no changes to these. these commands, so it could just use what was cached. Whereas, as you can see, 4.6 is about copying the files. This one was not cached because the files themselves have changed. Interesting. Maybe because the files have changed, this line afterwards for running the dependencies to run these files, we had to redo again. Maybe that's why. Update. So after a bit of sleuthing, I've learned that when you're copying new files or different looking files, what ends up happening is the other layers, the layers after it, usually get affected too, because the input state for the subsequent layers look different. Subsequent layers are now going to detect that, oh, because we're now copying a different Python file, technically the file system looks a little different. There's been a change to the environment. I should run pip install again. So it always happens to run commands. If you want to change something up top, the subsequent commands will usually have to rebuild too. So that's a new learning. But now that we've rebuilt it, let's go ahead and try to run our container. And there we go. This time it actually started properly. No errors, thank goodness. So the container is running. Let's take a screenshot of the running container. All right, let's go ahead and do that here. Put that in here. And we're gonna have to test the container, don't we, now that it's running? So in this moment of truth, we're gonna switch back into our other terminal, and let's just quit that. Actually, I think the safest bet is to actually just delete this entire other terminal that we don't need. This is the terminal that's running our Docker container. So let's click on that new terminal button and run the command to test our API, like this. Enter that, and we've got an internal server error. Why did that happen? What do you think? Do you want to make a guess? So let's expand the I got an error or no response, and we've got an internal server error today, so let's open this up. So if you see errors that say internal server error, switch terminals back to the one running your API. That terminal should be called Docker. Okay, switch back and check the error message that's in your terminal. Okay, in this case it says failed to connect to Ollama. So maybe Ollama isn't running? Let's see. Let's run the command to check if Ollama is running. And you can do this in your other terminal. Okay, Ollama is actually running. So if Ollama is running, but your query still says internal server error, it means that even though you've got Ollama running, your container can't actually reach it to generate the response. So what this means to us is your container is probably not listening or making a request to Ollama at the right port. So this traces all the way back to our application file. Let's have a look at the application file, and it says to generate an answer, okay, to generate the answer to send back to our learners or our users, we're going to use a tiny llama model, okay, that's fine. And then we're going to give them, the context of the question, the user's question themselves, and then the instruction to answer clearly and concisely. This function looks pretty innocent, nothing seems wrong, but Ollama generate by default tries to connect to Ollama using this localhost address. So this localhost address worked when we were running this API ourselves on our local computer, but would it work inside a container? Maybe not, because localhost, if a container is running this code, localhost to them just means Ollama inside that container. But, that's not really how it works, because you might have noticed our Docker file did not contain pulling the tiny llama model, and it also did not involve any commands for starting up Ollama, so we don't actually expect the container to have Ollama self-contained and tiny llama self-contained as well. we are actually expecting that the container communicates with our computer, this local computer, when it needs to communicate to Ollama, because Ollama is running on our host computer. So since Ollama can't be found, our app is pointing to localhost 11434. So the container is only looking into itself, can't find Ollama, returns the internal server error. So given all of this, you might be wondering, oh, but why did our Docker file not have the instructions for Ollama or for TinyLlama? Wouldn't that make things easier? It is definitely possible to do that, but running Ollama in a separate container or separate computer is actually a very common production pattern. It helps you scale Ollama independently from your API. It means that you can update the model without rebuilding your API container. It also means that you can use specialized hardware like GPUs for the model. So you're not reliant on the container itself having a really, really strong model, which could actually be more expensive. So for this project, we're keeping it simple by just running Ollama on your host computer. Even though containerizing it is a possibility, it's definitely an option. All right, so to solve this problem, there's actually a pretty simple solution, and it's to actually update the app Python file again. So stop your container first. Okay, we don't need our container running anymore. It doesn't seem like it's actually running great code right now. So let's just stop that, press Ctrl+C. And then we're gonna open the app Python file in cursor. Let's find the line that says ollama.generate. And we're gonna add a host parameter to tell it where to find Ollama. So that host parameter is right over here. Okay, and we're gonna add this here. Oh, seems like it got a little complicated here, team, doesn't it? Okay. All right. So let's just replace all of this Ollama generate into here. Not bad. Just need to indent this part. Okay, Python's very sensitive to indentation, so we just want to make sure we get this right. Okay, so now we've just added this line that specifies a host. So host.docker.internal is a special host name that Docker provides on Mac and Windows. It points to your actual computer, the host computer, from inside the container. So basically, this is going to let your containerized app reach Ollama that's running on your host computer when it wants to generate that response. Cool. So again, when we've corrected our code, it is time to rebuild the Docker image itself. So make sure to save your updated app Python file and run the command again for building your Docker image. Again, because there's been a change in our app Python file, it looks like layers 5 and 6 of our image needs to be rebuilt too. So cool, it looks like we're gonna have to wait. Awesome. So we've rebuilt the image and we're gonna start that container one more time. Ah! Is this third time lucky? Oh my goodness, it is. Okay, so let's go ahead and run the command to test our API one more time. Let's do this, team. Oh, we got another internal server error. Do we actually save this? All right, update team. After a bit of digging into the Ollama docs, I've learned that actually Ollama.generate again is just going to by default assume that the host should be localhost 8000, and that's not what we want. So the new command we should be using instead is Ollama_client.generate. And the good thing about Ollama_client is an option that where we can actually configure the host address. So I've reverted the Python file, but we do still need to mention the host is the Docker internal host. So let's save and let's run this and build the container first. Let's put this theory to the test, team. Okay, so the image is now built. Let's go and run it. Run a container. Let's see. Please, please, please work. Let's have a go. Internal server error once more. What am I missing, everyone? Oh, I accidentally duplicated the... Oh, what have I done? I think I accidentally duplicated this. Yeah. Oh, what happened? Okay, we do not need two of the same query, everyone. And clearly the other one is still using Ollama.generate, so this could be the reason why we're still getting an error. Oh wow, let's try this one more time, team. Okay, import Ollama. This is where it starts to duplicate. I must have done something with a keyboard shortcut. Save that. Rebuild the Docker image one more time. Oh, wrong terminal. This one is the one. Oops. Let's try that again, team. Okay. Fourth or fifth time lucky, we've built the Docker image. Let's run it. Let's see. What are we gonna see now? I'm so curious. Okay. Ollama client is not defined. What could this be? All right. I think I figured out that Ollama client is actually not something you can just call straight away. When you do Ollama.generate, you're actually calling the Ollama that you've imported. But if you're just calling Ollama client, this is not pointing to anything. Ollama client isn't something that just exists. You have to define it first. That's the reason why it says name Ollama client is not defined, and we must define it. Okay. Oh my gosh. Look at this. Cursor already knew the answer. So I simply have to click tab to show it, but you have to define Ollama client first and just say that we're going to create a new Ollama client, which means that we're going to set up an instance of Ollama, the service, that we will be able to find if we are to actually go to our hosts and go to our host 11434 port. This is a big difference from using the Ollama generate, which was actually using the container's local host instead of the host computer's port. So this is all port mapping magic that's happening right now. And the key thing is, by defining Ollama client, our container is able to access the LLMs and be able to respond to your query. So let's go ahead and build our container. I wonder if this is going to be the last time we do it. And that should help us have a working query. Let's see. Image built, run the container. Okay, do it. Oh my gosh. Internal server error. Client generate got an unexpected keyword argument host. Now that we have determined the host in this client, we don't need to define it in here. Okay? All right. Then let's remove the host from the definition inside the generate command, since we've already defined the host here. And let's go ahead and build our Docker image once again. All right, everyone. Seventh time lucky. I don't need to build it one more time, do I? I'm getting confused now because of doing all these steps again and again. But I mean, now we're, I think, experts of building and running Docker containers, surely. Okay. Let's see it. Wow! Oh my gosh. We did it. We did it. Well done, everyone. High five. Well done. Okay, so that actually concludes the main project. Isn't it so funny that we just repeated the last step maybe 20 times, but that was truly the last thing before we finished the project. We do have the secret mission, so I'm very excited to do all of that with everyone here. But looking at the result here, what this tells us is that our API still works even when it's containerized. All right, it still worked after 7 tries. And there are huge differences between running that API locally and in Docker. So if you're running your API locally, which is what we did in that first project, we were using our Python package, our version of Python and all of those packages that we'd installed using the Python virtual environment. And there's always a chance that it will break if the dependencies change. But if you run it in Docker, we're using a very consistent Python environment inside the container. It includes all the dependencies in the image. It works identically on any machine with Docker, so they don't need to install all those dependencies themselves. The container has already installed it for them. And of course, it's isolated from the system. So we're going to take a screenshot of that working RAG API. Oh my gosh. Can't believe it finally worked. What a success. So testing the API after containerization proved that our API was still functioning and could return a response to questions to the same questions. The difference between running locally and in Docker is, I think, let's talk about port mapping a little in this answer actually, is that we are pointing to our local running instance of Ollama when running the API locally. But the container needed to create, but the containerized API had to create a special Ollama host that maps to the correct port in the local machine instead of in the container. Containerization helps because it saves people the time and effort of sharing tools with each other. If our environments are different, it would take a long time to set up our environment just to run someone else's app. That's really one of the key benefits of Docker in a nutshell. It would just take much longer and much more effort to run someone else's app if it wasn't containerized. And if you didn't have all of the dependencies or the packages it needed for it to work. So, nice. Well done, everyone. Let's stop the container. All right. And press Control C to stop it. Well done. So, are you ready to share your Docker image with the world? That is what the secret mission is about. So, if you would like to accept this secret mission, we're going to push your Docker image to Docker Hub and learn how to distribute the container publicly. This is how professional teams often share a containerized application, whether for collaboration or for a CI/CD pipeline or to deploy it to cloud platforms. You have to push your image to a registry, or basically a place for storing Docker images so that someone else can access it. All right, so let's get into it and unlock our secret mission. Cool. So in this secret mission, get ready to create a Docker Hub account. We're going to tag your image for Docker Hub, push the image to Docker Hub, and then pull and run our own image from Docker Hub. Wow, we're saying Docker Hub 4 times here. But we're going to say Docker Hub one more time, because why do we want to push it to Docker Hub? So it really boils down to, we just want to make sure anyone, including you on other machines, can go to this public online place where you can just download your image and then you can just run it from whichever machine you're using. Docker Hub is also very, very easy to use. So pushing images onto Docker Hub is quite easy, and being able to pull and run it is also, in just like 3-4 commands. So I think there's a lot of value in being able to share your images beyond, just being able to build it. And Docker Hub lets you do that. So cool. In this project extension, we're pushing our container image to Docker Hub. Docker Hub is a container registry, which is like a GitHub repo, which is like GitHub, which is like what GitHub is to code. By pushing our image to Docker Hub, we get to publish it publicly, and be able to pull and run it from any device, computer. We're doing this because, actually I feel like we've just answered that. We're doing this because by pushing our image to Docker Hub, we get to publish it publicly and be able to pull and run it from any computer. Excellent. We're going to create a Docker Hub account. So a Docker Hub account, it does require, your email and a password and a sign up. So let's just go through that registration process together. On your web browser, let's check out hub.docker.com/signup. Okay. Cool. And let's just sign up here. You can switch over to personal, so you're using your personal email, and you can just type in your email here. Okay, set up your username and password, and let's just select sign up. Oh, it says cannot use this username. Someone else must already have it. Natasha loves projects. Surely that hasn't been taken yet. All right, success. So it looks like we've created our account. We just need to sign in now. So let's just use our handy username, Natasha Loves Projects. And the password, I totally did not forget it. There we go. Boom, we're in. Well, we do need to check our inbox to verify the email associated with the account. You won't be able to navigate to Docker products or manage billing without verifying the address. Cool. Well, I'd say it's safe to just verify your email so that you are able to just access the full suite of things on Docker. But looking at what verifying allows us to do, it seems like it's not entirely needed. So you know what? I'll be our guinea pig. I'll be our guinea pig, and I'll see if we can do this project without needing to verify our email. Okay. Let's log into Docker Hub from the terminal now so you can push images. Okay. And let's log in from here, and we're going to press enter. Oh, it says I've got existing credentials. That's my other account. We don't need that. I want to use my new account. So let's Docker log in one more time. Cool. And in my incognito window over here, let's open up this activation panel, and it says enter the code displayed on your device. No worries. The code is this thing over here. Oh, just realized you can't see it. The code is this thing over here. So let's go ahead, copy, paste that. Let's go. All right. Congratulations, you're all set. Good to know. And let's just press enter here. Oh, it says email must be verified before using account. All right, guess we cannot escape this email thing. Let's go ahead and verify our email. And to verify my email, I opened up this email from Docker that says please confirm your address. I'm gonna click verify email address like here. And it says successful. Great. So let's try this thing again. Docker login. Waiting for authentication in the browser. Let's copy this activate link and try activate one more time. Let's do it. This time the code looks completely different. And we should be able to confirm that. All right, we're all set. Let's see. Please authenticate us in the browser. Did that work? Okay, login succeeded. Oh, try to log me in one more time. But we're now logged in, so I think we're ready to push our image into Docker Hub. And the first step to be able to push your image is to give your image a unique name that Docker Hub can recognize too. Just like how we named our image rag-app, Docker Hub usually needs a more specific name that also includes your username. So seeing your username, which is unique to everyone that has a Docker Hub account, is going to help Docker Hub be able to attribute an image you pushed to the person that pushed it. And because you've authenticated to that user, it can definitely safely say that, yes, I can authenticate that it really was this person that pushed this image under their own name. Okay, so tag your image with your Docker Hub username, and we are going to just fill this in with the username. I know that mine is Natasha Loves Projects, so I'm going to type that in. Press enter. All right, and then let's copy this piece of code, and this helps us with tagging the image that we've already built with the name Natasha Loves Projects, or whatever your username is, /rag-app. Okay, so tagging means giving the same Docker image a new name. You're not duplicating your image, you're just giving it a new name that it can go by. So the image is still going to be called RAG app, but it also just has a second name now. Without tagging, Docker really wouldn't know which user or online repo the image should go to. That's why tagging it in this way is very, very important. And if you don't know where to find your username, or you're like, oh, I don't remember it anymore, don't worry. In your Docker account, you'll be able to see your username right here. Okay, and let's just check that the tag was created. If you were to try to see all the Docker images that you've created, you should see 2 from the results, not just 1. You know, previously it was 1, we only had RAG app, but this time we also have the Natasha Loves Projects tag 2. Yes! And notice that they actually share the same image ID, so you know that underlying both names is actually the exact same image. So we can now just push that image over to Docker Hub. Let's copy the code for that and paste that in our terminal so we can push. So this is probably going to take a few minutes depending on your internet speed. As you can see, there are multiple layers, each one matching to a layer that's inside our Docker file. And here, the 2 layers that are going to take a bit of time is this one, where you do have about 200 megabytes to upload, and this one where you've got another 166 megabytes to upload. I wonder if they correlate. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which I think almost matches up to how many lines our Docker file has got. But it does depend on how many layers our image has. But I can imagine if we were installing this many prerequisites, and we were also creating the vector embeddings, maybe those take time. And we are just pushing both now. I think we're on the way. It's going to take about 3 minutes total. That's cool. That's cool. While we wait, there's always something that we could do. How did you push to Docker Hub, and what are the advantages? I pushed to Docker Hub by running the docker push command to push my image where I referenced its new tag that has my Docker Hub username in it. Docker Hub is useful because it is public and free to use and lets us publish our image to the public. The advantage of pushing to a registry is that others can now easily use the application by pulling from the central public space for images. Very nice. That was perfect timing. I think we're all done with this, and the pushing has just completed, for every layer of our image. So it's awesome. If it takes longer for you, don't hesitate to quit the process and rerun it. That's definitely helped me multiple times. And it really does come down to internet speed as well. So if you feel like maybe internet isn't very, very strong, just give yourself extra time to let it run while you're doing something else. And I think that means that we are ready to actually go ahead and check that the image is on Docker Hub. So let's visit the repository's public page in your browser, copy the link here, and paste it here to check out your image right over here. It's online. And remember, I think I was able to, you should be able to just find this in the Explore tab too. Look at that, some of the most famous images are right here, and you're in their exact same space system. You're one of the available results. It's kind of cool, isn't it? So awesome to have your image publicly available to the world. If you're at this step right now, please share the link to your image, maybe in the Nextdoor community, in this YouTube video, any way that you can share it. It's so cool, isn't it? Nice. Okay, so check. We can even take a screenshot of the image on Docker Hub. I'll take up that offer. Okay. Great. And once it is public, we can actually just pull from that image ourselves. First, let's remove the local version of that image that we just built so we can prove that we're pulling from Docker Hub. So let's run this command for removing it. Oh, it says it cannot delete because a container is currently using it and that container is running. Oh, it's very, very common for this to happen where an image can't be deleted because a container that's using that image is running right now. But that's totally okay. We can actually visit Docker Desktop here to resolve that problem. So we've got containers running right now. We probably don't need any of these. So let's go ahead and just delete all of them. These, for reference, were all built during this project. So given that we're now actually pulling a new image, we probably don't need these containers that were built from the old one. So let's go ahead and clear all of these containers and images. Okay, let's go ahead and try remove Natasha loves projects again, and it says no such image. So we successfully deleted that. Very nice. And let's pull the image from Docker Hub. So we know for a fact we don't have any images in our local Docker setup now. So if we were to pull this, we're definitely pulling what we just uploaded onto Docker Hub. Okay, so that was it. That download was very, very fast. Nice. So now that we have downloaded or pulled our image, we can actually take a screenshot. So shall we? Okay, let's put that in the project guide. Okay, and now that we've downloaded our image, it proves that our image is truly accessible from anywhere. It means, if you share that link to a friend, the link to your repository, they should be able to just pull your image and use it too. So pulling an image from Docker Hub means downloading an image that's been uploaded, shared via Docker Hub. When I ran Docker pull, when we ran Docker pull, Docker was installing a local copy of the exact image that I just uploaded. The difference between building locally and pulling from Docker Hub is that I can easily switch computers and still be able to run my containerized API. This helps me work from multiple different places instead of just one. Okay, so now that we've pulled this image, let's try and run it, shall we? Let's run this image. Okay, it's running, and your API should start just like before. Doesn't look too different, does it? So this proves that your image can actually start. But let's test the API itself. Will it work? All right, let's run the command that queries what is Kubernetes, and phew, we've got a successful response. Kubernetes is a container orchestration platform used to manage containers at scale. Beautiful. This is exactly the document that we uploaded to our knowledge base, so we know for sure our RAG system is working, even after everything's containerized. Okay, so well done. You've just been able to prove to yourself that you were able to run that containerized API. And as a recap, the value of having Docker Hub. Now that the image is on Docker Hub, you can share it. Anyone can pull and run your image with the same command, docker pull, and just reference your image's name. CI/CD ready. Automated pipelines can now pull your image for testing and deployment, and all they have to do is, again, just run that same command, docker pull. And then multi-machine, you can pull the same image on any machine with Docker installed, and you can now tag versions and manage releases using different Docker images that you put onto the same repository. This is how professional teams often distribute their containerized applications, and you just did the same thing. Now, this project is project 2 of a 5-part series where there are going to be more projects that build right on top of what we just did. So, highly recommend that you keep your resources. They're all free to keep, but if you're not planning on doing the next project on Kubernetes, you are totally safe to just delete the resources. And even if you do delete the resources and change your mind, we can always show you how to set up your project from scratch again. Okay, so let's go ahead and do our final recap. Services we used were Docker, Docker Hub, we used Ollama, we used FastAPI, didn't we? And we also used the Chroma DB. Anything I've missed? Ollama, FastAPI Chroma, and technically also Unicorn, the server. Key concepts we learned include how containerization works, how to build a Docker image, how to write a Docker file, how to publish your Docker image. That was fun too. Plus pull from it yourself. And we've also got how long did it take you to complete this project? Well, this project took us approximately 2.5 hours, including all that error troubleshooting time. The most challenging part was preparing the app Python file so that the RAG API still works when containerized. It was most rewarding to push the image onto Docker Hub for sure. See the image public and even pull it yourself. Excellent. So thank you so much again for doing this project. Did this project meet your goals? This is the part where you can reflect on why you did this project today. So we did this project because we wanted to do a huge level up in our understanding of containerization, and why people do it. Okay. All done. Mission accomplished. Well done. You've learned how to package your API in a Docker container that runs identically everywhere. You built a Docker image from Docker file. You've pushed your image to Docker Hub for distribution, and you've also pulled and run the image yourself from Docker Hub. So we've definitely nailed not just local development of the API, but also the containerization of it. So the next project, we can deploy it to Kubernetes. Fun! Okay, well, before we go, we definitely have to check out our documentation. So let's check it out now. You can actually click on My Work to open up your documentation. And here you go. You've got your images and all of your responses all here. And if you'd like to share it as a PDF, easy as, all you gotta do is expand this, copy the live URL, and now you can just paste this URL anywhere so that someone can visit your documentation as a web page. Otherwise, you can click on share on LinkedIn, and boom, we've set up a template that can help you share this on LinkedIn with confidence. Okay. There are also options for sharing on TikTok, and there are also options for sharing on Instagram, Facebook, and X. So for those options, the post text is also copied into your clipboard, so you can just paste it into a new post whenever. And did you know you can change the theme? You've got dark theme. You've also got light theme. Yeah. It looks great, doesn't it? All right, everyone. So that brings this project to a close. That was so much fun. I hope you enjoyed learning how to containerize that RAG API with Docker. If you've got any feedback, any questions about this project, please know we're always here on YouTube, and even better, in the NextWork community. Hope to see you there, and hope to see you in your next project. Bye.